All right, good afternoon, everybody. We have 10 people joining us remotely, and 2, 4, 6, 8, 10 people in the conference room, plus myself. And in this quick course on how to use Windows Azure, we're going to first go over the basic concepts, basics of cloud computing. We're going to get familiar with what hypervisors are, what a virtual machine is, what a web role is, what a worker role is, and so on. Then we're going to look into the details of Windows Azure as a cloud platform. And then we're going to take a look at the architecture of how to deploy applications in the different technology stacks, including .NET, PHP, and Java. And finally, we're going to look at some live examples. How to do it. We're going to quickly look at the Azure control panel, and I hope you enjoy it. If you have any questions, just interrupt me anytime, and go ahead. All right. So basics of cloud computing. So what is cloud computing? Cloud computing is the use of hardware and software delivered as a service over the internet. This is a major difference between, there's a major difference between cloud computing and grid computing. Grid computing refers more to a cluster or servers that are purposed towards the same end, as opposed to cloud computing, which is a bunch of servers purposed towards different ends. In grid computing, you can perform mass operations, but all of the machines that are running code there are solving a problem. Here in cloud computing, there's multiple machines, sure, but they provide different services. So I hope the difference is clear so far. Windows Azure is a cloud computing platform, meaning it provides infrastructure as a service, platform as a service, network as a service, storage as a service, and database as a service. It provides a little more than that, but these are just the different problems or the different hardware and software as a service that are delivered over the internet. Anybody has a clue as to why it's called cloud computing, where the name comes from? In high-level infrastructural diagrams, previously the internet was represented as a cloud, in the shape of a cloud, because of its complexity, and it's exactly that. It's because there's a number of services, or a vast amount of services, and vast complexity, and that's why we represent it in diagrams as a cloud, and that's why we call it cloud computing, because of a variety of different services that are offered in this cloud, or in this infrastructure. Now, let's look at what the difference is between horizontal scalability and vertical scalability. Does anybody have a clue? Can you explain, Emilio?
When you grow horizontally, you need more horsepower, more capacities on the computer that you are using. You have to increase the capacities of your computer. And when you grow vertically? No, the other way around.
It's the other way around, exactly.
You grow in little machines, more machines.
Right. So the idea, just to be clear, in the vertical scalability model, we increase the RAM, increase the hard drive space, increase the network number of network adapters. We team up network adapters to the same switch. We do a number of very expensive, we purchase a number of very expensive components, typically, and we just keep adding on to this big machine that will serve our purpose in order to handle bigger loads of people accessing the servers and people trying to consume these services, or the software that lives in this vertically scalable system. In the horizontal scalability model, we use commodity hardware, meaning any machine will do, as long as we properly configure it and as long as our software is ready to be deployed to each of those little machines or commodity of hardware. As long as the software doesn't have any problems with multiple instances of itself, then we call that horizontal scalability. What do you guys think big services such as Gmail or Hotmail are? Do you think they run on a extremely large server, or do you guys think they run on a number of little or commodity hardware servers?
Yeah, well, I think that Google is famous for using the horizontal one, because they have like a distributed file system that they build their own for.
That's a very well-known case of horizontal scalability. The distributed file system that has been named on a number of articles on the internet and on magazines, that's the perfect example of horizontal scalability. The reality is most other services already do horizontal scalability as well. Not a lot of the services do vertical. Now, moving on, when horizontal scalability has its own problems. There's a space problem, because you can't put 1,000 computers in a smaller room. There's an energy problem or a power problem, because the power consumption goes up. If even a server that has been vertically scaled, even if it has one 650 or 1,000 watt power supply, and even if the horizontal ones, the little ones, have each 250 watt power supplies, then the consumption is typically going to be a lot higher than the horizontal scale, right? How about think about like a switch, right? When you're trying to set this complex infrastructure up, you're going to end up with huge switches, and each network adapter going to each of these switches, and the switch is going to have to be able to handle a number of different speeds in the links, and you're just not going to Well, the simpler or the higher level answer would be we combine both. How do we combine both? We have something called hypervisors. Hypervisors come from different vendors. Examples are VMware, and in this case, Windows Azure is based on Hyper-V, which is the hypervisor technology from Microsoft. And what hypervisors do is they take advantage of the computing and power resources on one machine to create instances of little or smaller machines within that physical server. So we create virtual machines in a hypervisor, correct? So far, everything is clicking, or is it? Do you have a question? Okay. All right. So, and what this means is, we don't need a very big server for to host a web server. We don't need a very big server to host Active Directory, for example. But we do need a big server for databases. So we can say, okay, let's put 8 gigs of the physical RAM to this virtual machine, 4 gigs to the web server, and 4 gigs to the Active Directory server, for example. And that way we have a number of virtual machines within the same machine, saving power, saving space, and saving saving administrative costs, because it's much easier to move a virtual machine around from server to server, from hypervisor to hypervisor, than to physically move a virtual machine. Network adapters, yeah, you may have like a really powerful 4 or 8 port adapter in your physical machine, and then you team them up. But in the end, it's just a virtual switch to which all these computers go to. So, what is Windows Azure? Well, just a number of programmable hypervisors. That's all it is. It's just a consistent set of infrastructure or hardware that is just placed in a secure space, and just has Hyper-V, and Hyper-V has an API, and you can create virtual machines, and within those virtual machines you're going to find distributed versions of SQL Server. You're going to find distributed versions of, or you can create distributed web applications. You can configure virtual firewalls. You can just use the operating system itself. You can run all the virtual machines that we're going to be looking at here are Windows Server 2008 R2. So that's the default operating system that gets created when you instantiate a virtual machine. So far, so good?
Yes.
So, as I was saying, Azure is based on Hyper-V, Microsoft's hypervisor technology. And right now, its 2012 version is provided completely free of charge, and it's a standalone edition. It doesn't have a GUI, but command line can do so. So it's free to download, free to use. If in enterprise scenarios, we're going to have Windows Server 2012 Data Center Edition in order to be able to have a GUI and provide clustering facilities and still have a number of virtual machines running on that physical machine. So some cloud services offered in Windows Azure, database as a service, SQL Azure, platform as a service. We're going to look into web roles, worker roles, and websites. We're going to let that out for now. But once you understand the web role, websites is for the newbies. It's just easier to set up. Infrastructure as a service. There is a new role coming out. Right now it's in the preview state, and it's called a VM role, in which you are going to be able to run any operating system. You can actually do that now if you sign up for a trial. You can run any distribution of Linux or any distribution or any version of Windows. Storage as a service. We have blob storage, which is basically a persistent file storage mechanism for big files. Table storage, which is a form of NoSQL. Are you guys familiar with the concept of NoSQL? A form of NoSQL. Are you guys familiar with the concept of NoSQL?
Non-relational databases?
The non-relational databases, exactly. So it's table storage, and something I didn't mention there is the queues, in which you can queue up objects, but it's a service we're not going to be looking at today. Network as a service. We have the Connect service, which is a machine-to-machine, and the virtual network, which is a site-to-site, uses standard IPsec protocols to connect to two or more subnets across the internet securely. All right. Any comments, questions so far? No? All right, so how do we use Azure to make scalable, reliable applications and that don't have single point of failure, and can grow as the requests grow? This is the basic architecture, and remember, it's just Windows and IIS. There's nothing weird or crazy about it. I think everybody here has at least looked at IIS and has used Windows in the past, so no worries. You know, it's just Windows and IIS. Also, remember that images are volatile. Once you image a virtual machine, it can boot up and re-image itself with the original image. So all the data that you save in that disk is gone. Okay? So we need a mechanism to save files into somewhere that is persistent. So, for example, in PHP, you have session management in the file system, right? So anybody can think of a problem deploying a PHP or an ASP.NET application on two machines, the same application on two machines, and saving the session in the file system, knowing that these images are volatile. What do you guys think is the problem with that?
Could you explain a little further?
What happens if you have a concurrent user, for example, trying to access the same data in different instances?
Kind of, actually. It's so in front of your instances of the same application, you will have a network load balancer, and you're going to have the two instances. And if user A makes a request and it ends up in server B, and the next time, given that HTTP is a stateless protocol, the next time the same user makes a request, if it goes to the other server, the other instance, it's not going to have its session data, i.e. authentication data, or any of the session variables we're storing for that particular user. It's just going to be, part of it, it's going to be here, and part of it is going to be in the other server. So chances are that person will need to re-authenticate it. And
How single sign-on?
not necessarily, no. It's persistence in Java, right? You can have session variables, right, in Java too, and if you say, for example, what happens is when you create an HTTP session or a web session, the cookies are sent back to the client with a token that identifies the user. Right? But if it ends up in the other server and we're saving sessions on disk, on each individual disk, we're not going to, we're going to lose the data. We're going to lose the, it's not that we're going to lose it, it's just going to be, part of it it's going to be here, and part of it it's going to be in the other server, and we're just not going to have a consistent experience, right, for our users. Yeah.
Can we use Datasheet for making that?
Yes, absolutely. We're going to look at that. That's one way of resolving the problem. Yes, we're going to we're going to get into that a little later. In order, okay, so do you guys understand why we need not to save, and why the file system is not a good place to save data in distributed systems? So, all right, we're going to need a minimum of 2 instances of our web application for, I believe it's 4 nines reliability that Microsoft is offering, or 5 nines, I can't remember. And that's that's the service level agreement that they have with the user. If you're just running 1 instance, the SLA is not valid. They don't take responsibility for downtime. Okay. And for .NET and PHP applications, you will use web roles, and the reason is web roles are the same as saying as we're going to be using IIS. Java has its own application server, which in some cases it's Apache with Tomcat. In some cases we're going to have JBoss. In some others we're going to have Glassfish. But we're not going to be using IIS in Java, right? We're going to be using other types of servers. And those are called worker roles. But in the case of .NET and PHP uses Fast CGI, the Common Gateway Interface, and it integrates with IIS. Therefore, we can use web roles. So for .NET and PHP, again, we're going to use web roles. And our deployment image will have deployment configuration. So it's just an XML file that will tell Windows Azure how many instances of the role we're gonna instantiate and what the size of those instances are. We're gonna look at that shortly too. We're also going to define what ports are going to be open for this application, where these virtual machines and the network load balancer will listen on. The rest of the ports are shut down. You cannot access anything on that server except for what you define in your firewall ports. It's also part of the configuration. Now, you're going to have your application code, and part of that is going to be your session management. You can send it to table storage, SQL Azure, or ClearDB, which is an Azure version of MySQL, for example. And these are just examples. As long as it's persistent and distributed, and as long as you're not saving it in the file system, we should be good. There's no worries there. All right, so problem with our reporting device. So again, session management, we don't save to the file system. If we're migrating existing code, what do we need to do? We need to ensure that the session is not in proc or in the file system or using any type of local storage. Just keep in mind that your request will end up in any of the servers, in any of the instances in the game, right? It'll hit a random instance. Let's say you have 10 instances and one user, the chances are that on the next HTTP request, it's going to end up on server 5 as opposed to server 1. And the session's going to be lost at that point. File uploads. We have applications that where you upload files. So avoid storing files in the local system. If you're going to be storing files, you can use blob storage or use the database for storing these files. Never use a file system, local file system, because the image gets erased at any time. They don't tell you when it's going to happen. When they upgrade the hardware, it's gone. Your image is gone. Your database access. Here, if you're using SQL Server, it's as easy as changing the connection string, because SQL Azure is probably 99% compatible with SQL Server. So it's just a matter of changing the connection string. And in the case of MySQL, there's a very affordable solution called ClearDB. It's based on Azure too, and I would recommend that. So that's your application code. In terms of migration, you would need to, number 1, configure session management. Number 2, configure file uploads. Make sure we're not writing anything to the file system. And the database access, make sure we have the drivers, up-to-date drivers, and connection strings that are compatible with SQL Azure or ClearDB in these cases. And then you're obviously going to include your assemblies, and in the case of PHP, your extensions, right? The PHP runtime and the PHP extensions. All right. Now, in Java, the story is a little different. Here, it's just Windows. The Java virtual machine runs on Windows. So what's the problem? Well, the problem's the same. We can't use the local file system. Sure, we can use it for temporary storage or for anything that we don't care about. But just keep in mind, again, that your Tomcat and that your config files that you originally uploaded will be reset to their defaults. So you can't change anything in the application because, again, it's volatile. Again, minimum of 2 instances. And in this case, we're not going to use web roles because we don't need IIS. We're going to use a form of deployment called worker roles. Right? I'm going to show you that in code as well. So your deployment image. Again, virtual machine instances and size, and your firewall ports. That's standard for any deployment. Then your application code, your session management. This is typically managed via the persistence mechanisms. In the webend folder, there is a file, an XML file in which you can configure where the session state goes. Can anybody refresh my memory? And
WebXML?
Web.xml, correct, yes. And make sure the JDBC driver for SQL Azure, in the case you want to be using SQL Azure, is referred is in your jar list or in your lib folder of the application server that you're deploying, and make sure you reference that in your web.xml. And we're going to look at an example. Again, file uploads, they can go to blob storage. Blob storage and table storage are just REST APIs. So you can call them, there's readily available libraries already. You can just download the jar and just call them directly with, like, as if it were an API. Just, you provide a username and a key, and off you go. You can get the bytes, or you can get the string. Or if you want to do things manually, you just create a web request object, and off you go. You can access the service directly, even from a browser. Well, not from a browser. You need to insert headers to tell Azure which code, which user, and so on. And database access, again, SQL Azure or ClearDB. And we're going to have to write a little bit of startup code, unfortunately. So the startup code, what it's going to do is you're going to, instead of uploading a big fat image of your the JDK or the JVM that you're going to be using, plus like the application server, plus your application, and upload that every time we make a modification. What we're going to do is we're going to upload those zip files. We're just going to zip them. We're going to trim out all the documentation and all the useless files that come with the Java virtual machine. We're going to strip it out. We're going to upload it to blob storage, and we're going to have our startup code download it, unzip it, install it in the host operating system. The same with Tomcat or JBoss, and run the command, run the start.bat, and off we go. We have a perfectly functional application server on the cloud. And you're just going to have, again, same thing as in any other scenario. You need to have the Java virtual machine or the JDK, and you need to have the application server with your jars. Right? But that's no news for anybody. All right, so here's all you can find, and I'm going to share this presentation with everybody. Here's where you can get all the resources. I'm going to just open it up just so you see. So we have the tools for .NET, for PHP, for Java, for Python, and for Node.js if you want to use them. And you can do manual installs or web platform installer installs. Web platform is a tool that just allows you to install everything very easily. So, all right. So for .NET, I'm going to open up. So basically, the steps are get the Visual Studio Toolkit and the SDK. You can use Web Platform Installer, and let me show you Web Platform Installer. Let me show you it. This is a Web Platform Installer. It's free. It's small. So you can go to, for example, the Windows Azure folder, and you can download the Azure SDK for PHP. And that contains stuff like session management via table storage. You don't have to use the REST APIs manually. You just have classes that do all that stuff for you. Same for, let's look at Java stuff.
Did you have it installed already?
Yeah, I may have it installed already, yes. All right, so you can obviously get a copy of Visual Studio Express 2012, and it supports Windows Azure deployments. You can for Java people, you can use the SDK from the command line, but I highly recommend you just use Eclipse, deploy your application, zip it up with your deployed application. If Tomcat has a folder in which all the deployments are, and just zip it up, upload it to blob storage, and stick with the workable startup code. So we'll take a look at that. So for this, we're going to need the Windows Azure SDK for .NET, Visual Studio 2012, October 2012. I already have this installed, and it'll install. The nice thing about this is it'll install any dependencies on the SDK and the tools. And the SDK comes with the compute emulator and the storage emulator, so you can test whether or not your application will run on the file locally. You don't have to create a new deployment and put it onto staging and then test it out to see if it'll work. Create the solution. Oh, sorry. I'm going to open up the solution. Actually, I'm going to create it from scratch. One of the side notes is you always need to run Visual Studio in administrator mode, and the reason is that it needs to start the compute emulator and the storage emulator, okay? So I'm going to go ahead and do new project. I have a cloud project here, Windows Azure Cloud Service, and that will allow us to create web roles or worker roles, okay? So in this case, I'm just going to call it lab.net. And here I have a screen where I can add any type of role. If we just want to add an empty worker role, we can do that. And there's templates also for MVC3 and MVC4. Okay? We're going to go ahead and do a very simple MVC3 role. And you can edit the name. And obviously, the solution can have multiple web roles and multiple worker roles. So you can create instances of virtual machines that handle a number of services. So it's creating my project, and I'm just going to create a very basic empty solution, and we'll go through the configuration real quick. It's adding a bunch of libraries here. We'll just get rid of those shortly. Under scripts, we don't need any of this. We have under content themes, we don't need any of that either. All right, we have an empty web application. Let's create a very simple view for and we're just going to call it index. And let's create its controller as well. And I think that's it. Now, let's review what this application. All right, let's first test it out, see how well it works. See, it initializes the storage emulator as an administrator. You're probably going to get a firewall security warning. You just allow access. And should be a fairly empty. Yep, that's it. That's all we got. All right, now let's make sure the solution is ready for SQL Azure or for Windows Azure and ready to be deployed as a web role. The first thing we're going to do is we're going to look at the web config, and if you all right, here it is, session state, mode in proc. That means that each instance will keep the session objects or the session state in memory, in the machine's memory. So again, we can't write a memory. We can't write a memory. We can't write a disk. So we need to do something about this. We can't just keep it as simple as this, because this will fail. It's a little strange that the template doesn't handle it out of the box, but that's what it is. So I already have and the code will be provided as well. So. So we need to get rid of this. We need to replace it with something that makes sense for Azure. Meaning we need to handle sessions in SQL. And what I did here, I just commented this out, the session state, and instead of session state mode in proc, we're going to use session state SQL server, allow custom SQL database. This is a standard. It's not SQL or SQL Azure specific. It's a standard configuration in ASP.NET applications. However, you do need to configure the database with this little program here. I'm just going to run it and show it to you real quick. So, select, I'm going to remove all application services from the existing database using, sure, we can use Windows authentication. And I created a database called Azure Sessions. And I'm going to remove all the tables from it. Let me show you before I remove them. Here under databases, I created this Azure Sessions. You're going to do the same in the control panel. And it creates two small tables, ASP state temp applications, ASP state temp sessions. That's what this little program does. Nothing too complex. It just runs a script, a SQL script, and prepares this SQL provider to store session data onto that database. Now let's use the session a little bit. And we're just going to do it directly in the view. We're going to change this, and we're just going to simply count. If it's not set, the session refreshes. Just set it to 0. Otherwise, add 1, and just show it in the page. We're just going to save that view, run it, and we're going to inspect the database tables to make sure that the session is being stored in SQL Server and not in the file system. All right, so session data refreshes 0, 1, 2, 3. All right, let's make sure that that is in fact the case for the sessions table. I should have a session created just now and this is UTC, right? So you're going to see that it's tomorrow's date, but in fact, if you turn it into UTC, oh, lock date local. Okay, there it is. All right, it's 6:25. Yeah, we're storing sessions in the database. That's good. So we resolved that issue. You can use the table storage APIs as well, but that's another session. Right now, I just wanted to show you that SQL Azure is just SQL, and we can use it for session persistence. And we're going to take a look at the configuration. This is going to apply to any technology, so pay close attention to this one. If we double-click on the My MVC roles, we can select the amount of instances to create. Right? We can create, remember, it's minimum amount of 2. And VM sizes. Most of the time for web servers, small or extra small will do, and they're very cheap. They're anywhere from $8 to $16 a month. So you can run a website with about $30 a month.
What are the
We can look at the website here where it says learn more about the VM size, and we're going to have a table here that says, all right, so CPU cores shared, it's a little over 2/3 of a gigabyte and 20 gigabytes of storage locally. And 5 megabits of bandwidth. For small and then medium, for extra large, we have 8 CPU cores, 14 gigs of RAM, and a number of resources. And you can obviously sign up for a free trial here. I'm going to sign in and go to the main page, and here's the portal. This is my management tool. And these are the services I have here. Storage, for example, we have a couple of storage accounts, databases. It's loading. Cloud services, these are the roles that we've created. And let's just click on all items. And you can see the item type. It's a SQL database, all these. These are cloud services, and these are storage accounts, either a table or a queue or a blob. These are worker or web roles, and these are SQL Azure databases. You can easily create new services by clicking on New. Again, you have the virtual machine role in the preview. You have the mobile service. We can talk about these later. But what we're going to be using is multi-access control. Where are my cloud services? We can create a new cloud service, and we're going to go for custom create. We can specify sample app.cloudapp.net. Obviously, we can update our DNS records to redirect to this particular one, and we need to choose an affinity region. Where are most of the users? Where are they going to be accessing our application from? We're going to do East US, for example. And we can check and deploy a cloud service package now. Then I'm going to move on to the next one, and I'm going to say sample deployment. And here's where I provide the files that I create with Visual Studio. Okay. Back on the settings, we're going to have the endpoints, and this is our firewall configuration. Remember, we're under my MVC role configuration, and the endpoint can listen on HTTP port 80. Okay, and the local storage, nothing, no certificates, no virtual network. Once we're done with this, we can create a package and service configuration. We do cloud, build configuration, release. Obviously, this is wrong because I've configured the application to access my local database to keep sessions. I just want to, here in the output window, you're going to see that publish one succeeded. 0 failed, and I'm going to look for this package here under, it automatically pops out this window here and gives me the package and the service configuration that Windows Azure will be using here. So if I browse from local, I should be able to go to see projects, packages, no, not I'm sorry. You know what, let me just copy this. Bin, release, publish. Alright, that's what it is. And under the package, I select the CS package, and under configuration, I select the configuration. And this is the same procedure for all technologies. It doesn't matter which technology you're using. Alright, I'm not going to create the service. And obviously you will need to create your SQL database, and you can manage these databases very easily. And I can do quick create, database name, Azure sessions. and I can select a subscription and a server. Right? So that creates an instance of SQL Server on the cloud, just as if we installed SQL Server locally. Connection string will be given to you here, for example. If you go here and connect to your database, view SQL connection strings. Here it is. So for ADO.NET, for ODBC, for PHP, and for JDBC. Correct? That's what you're going to be using. And that's pretty much it for .NET. So back to our presentation. It's just a matter of creating the solution, create the SQL Azure database, create the session tables with the little program that I showed you. It's under the .NET Framework folder where the .NET Framework gets installed, and configure SQL Azure for Azure Firewall for access. That's another consideration we need to take for any deployment. You need to configure the database or which IP addresses will be accessing this database. So if I click on Manage Allowed IP Addresses, it shows me what my current IP address is, and I just can add it to a list. Sounds good?
If I move the instance of the virtual machine, also the IP address changes.
No, this is which IP address is access to a particular database.
For instance, I have an application that the customer IP. If I move that image from the virtual machine, the IP is going to change.
You cannot move it to another virtual machine. This is automatically managed for you. You don't need to move them around.
So my IP is in every virtual machine for the city.
They have a private IP address. Each of these virtual machines, they have a private IP address, and the load balancer is which has the public IP address. The virtual machines do not have, and you seldom need to know the private address of these virtual machines. You don't need it. All you need is, and this is if you want to manage it from the outside. Right? If I want to connect SQL Server Management Studio, I'm gonna, let me see if I have a connection already set up here. All right, here's one, for example. And the server names will look a little weird, like a number of random characters, but that's normal. And again, like I said, you can extract this from the connection strings here. If you go to the dashboard, you can see that this database, its name is UZ1, whatever. And you can manage it online too. You can query it, you can create tables, so it's like a mini SQL Server Management Studio based off Silverlight, which is pretty cool. All right, back to the presentation. Create the SQL Azure session table. Configure SQL Azure Firewall for access. We saw how to do that already. Configure database access connection strings. We saw that too in the web config file that we changed. Emulate the solution. We've done that. We've emulated the solution and configure and deploy. I already showed you how to create a package and how to upload it to the cloud. You have very nice facilities. Also, you don't need to create a package and then manually upload it. What you can do is just right-click on the cloud project, and you can just say publish, and choose your subscription. You manage your subscriptions, new, and select the certificate that you want to use, the ID of your subscription, which can be found in your subscription in the portal here. You go back to the dashboard and you can they can't listen. All right, give me a second. Can they listen? All right. Okay, back to this. The subscription ID can be found right here in the bottom. It's a longer number. And again, going back to Visual Studio, you can enter this here. You would leave this as it is, and you would just enter a subscription. And once you have that, you can select the cloud service that you just added, put it in staging or production, select a build configuration, hit next, and it will automatically upload your package and your configuration. This applies to any technology as well, any technology stack. All right, that's I think that's it for .NET. Now to PHP. Let's go to PHP real quick. If you are a PHP developer, you most likely already have IIS and Fast CGI enabled. All you will need to do is to go to your installation folder for PHP in IIS and copy these files, the DLLs and executables, in the PHP installation folder over to a subfolder in the project. That's the same as if we were including the JVM. These are the dependencies that we have for PHP. So we include a bunch of extensions, a bunch of DLLs and the CGI executable, and in this particular case, I will be managing the session via table storage. And what I did, I downloaded the Azure SDK for PHP, and that's just, again, a number of classes that allows you to access a REST service very easily. It's taking its time. It's down. Alright, anyway, it's there, and it's just a zip file that contains the Microsoft folder and contains a bunch of classes. And I wrote a little init script. I defined the environment. I added an included path, which is my ink folder here. I require the auto loader, which is what allows me to resolve the dependencies on each of the files for the SDK. If the environment is not the debug session, see, here's what you'll see in. I'm going to create a storage client for table storage, connecting to the table.core.windows.net address with my account name and my authorization key, which again you can extract from a control panel in the Azure control panel. If not, if it's a debug session, which I have defined here, that it is a debug session, I just create a new storage table client, and this will use our emulator. The emulator in reality is using SQL Server Express or LocalDB to emulate a storage engine. When you set these tools up, dependency may be LocalDB or SQL Express. LocalDB is just a new and improved version of SQL Express. You instantiate the session handler, which already comes out of the box, and you register it, and you do the typical session start. For PHP guys out there, this is very this is mandatory if you want to use sessions, and the rest is pretty simple. For the index, I'm just going to go to source view. Very simple. I'm using, again, very similar code to that of MVC. If it's not set, then set it to 0. Otherwise, add 1 to the refreshes. And just print it out here. Nothing too complicated. What we do need to do is, and we always need to do this regardless of whether or not our PHP setup is local on a server or in Windows Azure, is we need to configure our PHP ini. And one of the more important things is don't set the extension directory to something fixed, because you never know which drive in the virtual machine your code is going to end up in. So when Windows Azure re-images your virtual machine, it could be drive B. And this configuration entry would never find drive B, right? Or E, for example. With this one, using relative paths, everything, same goes for Java. A lot of the configurations, you guys are used to specifying absolute paths. Avoid absolute paths because drive letters change from deployment to deployment. you may end up with drive X. You never know. So this is one of the more important lines. Here is where I'm specifying or enabling all my extensions, and I'm enabling WinCache, which pre-compiles the code. You can get WinCache from Web Platform Installer. And PHP binaries as well. You can just say, oh, I want to install PHP, the SQL Server driver for PHP, PHP 3.19, the PHP manager for IIS, and WinCache. To do all. Windows Cache extension 1.3 for PHP 5.3. I don't have them here installed because I manually install. But in either case, it's a valid option. That's it for the configuration. So all you need to do is include your, typically you're going to find your PHP binaries and C program files, PHP. So you don't need to copy like the text files or the news or the license or all this stuff that doesn't make sense, right? All you need to do is copy your exe, your DLLs, and your extensions. We're not going to be linking libraries from C, so forget about including the lib file for dev, right? No worries, no need. So this is where you can find your files, and program files, PHP. One important, very important thing about the configuration, you will need a web config because it is IIS, and you will need to specify that the handler is PHP via fast CGI, and that all the CGI code will be specified with the PHP extensions. We're going to use the script processor, roll root, apt root, PHP, PHP CGI with the PHP INI file, right? This is the same as configuring fast CGI in IIS, and very similar to Apache too. And the module is the fast CGI module, and you don't need to specify resource type. Now, for the fast CGI processor to run, we need full trust. We can't have medium or low trust in the application. So we're going to tell the deployment configuration to use exactly that. If I open up that one here under roles, I really need to run that at the full trust level. Here's the setting right here, full trust. Not partial trust, I need this at full trust. And that's it. Let's see how it runs. Again, if you're using MySQLi as an extension, you see, I didn't start the application or Visual Studio in administrator mode, so I'm just going to close this down for a bit, reopen it up. That's the only caveat. and reopen my solution from here. And we are going to run it. See if it's going to show you the compute emulator. So this is my compute emulator. As you can see right now, we're running a deployment 18. It's the 167th time I've run a session here on the compute emulator. And this is our screen right there. So you can see that it has 0, instance number 0. I can run 3 or 4 instances, and I can take a look at the log here, calling run, calling on start, and I'm going to show you also the Azure storage UI. And remember, I told you guys it's a REST service. That's exactly why it's HTTP endpoints as opposed to a database or whatever, because it's just typical regular REST services, HTTP-based REST services. So here's my PHP application running on IIS as a web role, and I'm refreshing. As you can see, session is being stored in table storage. So we got the refreshes equals 5. Refresh once again, refresh, and I'm up to 8 now, and as simple as that. So again, going through the steps. Configure the handler, which is a fast CGI, same as with any other IIS application. Download and include your PHP SDK. Write a small init script to instantiate and register the session handler, and configure your service for full trust. And obviously include the PHP runtimes here, right? And configure your PHP INI, because to use relative caps, never use absolute caps. So far, so good. Is it fairly clear? All right, we're done with PHP. Now moving on to Java. See, I see in the log here that it's stopping and it destroyed it, and it's no longer there. It stopped. This is a summary. Just configure, do full trust, create the table storage space, configure Azure firewall. You have to do, a lot of these steps are very common to all technologies. Again, remember, it's just Windows. It's nothing complicated. Yeah, you don't have a GUI, but you can make it do whatever you want. It's a virtual machine, and it's yours to use. Right? All right, same with Java. With Java, you're going to not worry about Visual Studio initially. You're going to open up your Eclipse development environment, and you're going to write your application. And if you're used to using Tomcat, which is very lightweight, very nice application server, very easy to configure, you're going to find that most configurations are done via the web.xml file in the webin folder, and it has a Glassfish is another very nice application server that runs on, or that I've ported over to Azure, they all run very nicely. So nothing to worry about. You just write your application in Eclipse, you deploy it, you go to the folder of your application server, your Tomcat or Catalina, and you zip it up with the application deployed, and I'm going to show you one of the blob storage this is a Cloudberry Explorer for Azure Blob Storage. So what you would do here is just upload the zip file for your application server with your deployed application. Deployed and configured. You will need to already have configured the session management to live in the SQL Azure database. And you also need to have your jars and your lib folder for the JDBC driver.
You have the examples for those?
Yes, I'm going to show you. Yes. And you just upload it using, there's a number of tools you can use for, yeah, that's an old one. I don't think I have the new ones. Yeah, that's, you can add your subscriptions here, your storage subscriptions, and just upload your zip files. That's all you need to do. And zip up your JDK or your JVM. If you're running in production, typically you don't want to use a JDK because it's a little heavier. It runs with typically debug symbols for dependent libraries, so you want to use just a final JVM. Create the solution in Visual Studio, and the solution in Visual Studio is going to have no Java whatsoever, and I'm going to show you. And all it's going to do is just going to download those zip files, extract them onto the drive, get all the paths inside the virtual machine dynamically, and configure your application server to run correctly on the fly. That's the same for the previous ones. All right, so let me open up the All right, so I have the Tomcat Azure solution. Somebody dropped.
By the time they lose the audio?
Yeah, somebody might have left. So again, we're going to create a worker role. You notice how there's a little gear here in the Tomcat worker. Again, we're going to run full trust. And make sure you set up your endpoints. I'm going to run on port 8080 because by default, and just select TCP. Do not select HTTP because HTTP it's going to do stateful inspection of the packets, and it may rewrite the headers or something weird. Let's let Apache handle it directly, not the network load balancer. We just want the TCP connection, and the TCP port open, and let Apache handle the rest. Okay? And then for the worker, guess what? We really don't have anything related to Java. And the reason why we don't have anything is you're going to see that I have a Tomcat download URL, and this already contains my application, or it used to. It doesn't anymore. I had a test account, and it's no longer active. But that's where I zipped it up. I zipped up the folder. I zipped up my JRE6 I uploaded and zipped it up, and I defined these constants. The worker role will have just like a console application. It'll behave a lot like a console application, and I'm just going to write out what it is doing so I can see it in the output window. So I have a few functions here. Download file and zip file and run Tomcat, and just stay there, just let me know you're alive, and write it out to trace. So download the file, JRE download, and save it as jre.zip. Download the file, TCM, and save it out as tcm.zip. Tomcat with my application. Unzip both files and the application path, and we're going to see what this application path does. And finally, run Tomcat. Is that sums it up? And that's what you would do anyways. Is that you guys get this or no? Are you guys clear? Okay. What is application path? If you go to the definition, you need to get to the environment variable and then /app root. That'll give you the drive letter and the base path on where this thing is running. And if we're going to download and zip files, we better know where those files are getting unzipped, right? Because otherwise, how do we know where to extract it? What is run Tomcat? Basically, what I'm going to do is I'm going to create a bat file, just a batch file, and set my Java home and to the application path /JRE6, which is where I unzipped my JRE, and do the Tomcat path and just run the bin /startup.path, and it'll start up my Tomcat server with my deployed application, and but that's writing out the batch file. Now I need to run the batch file, and for that I need to create a new process, and that is under system.diagnostics, and select a, we're going to have a windowless process with the run.bat, and do not use shell execute, and set the working directory to application path. Once we have the startup parameters, we start the process, and that's it. We start the process. We don't wait for the process to finish. We just let it run, right? And at this point, our worker role has branched out to a new process for Tomcat.
Maybe that is just like configuring when Windows is a
Path.
Yeah, I mean, but the variables.
Yep. Yep, the environment variables.
Environment variables.
Because it's a fresh, clean, brand new virtual machine, it doesn't know where Java Home is, so we need to tell. You need to tell it, and then finally we need to once we told it, we need to start the server, right? So, but we already defined a start of a Java home. So, and this is the function download file, and just so you get comfortable with it, like I said, it's just a REST service. So all we need to do is create a web request for the download URL, even if it's blob storage, and use a GET request method, and just keep reading the bytes and saving them to a file. Once they're downloaded, that's it. It's just a REST API. Right? Nothing crazy about it. And the Tomcat path, in this case, I had it set to the base path / Apache Tomcat 6.0.35. And how do you configure your application correctly? I have JBoss here. All right. So first of all, you need to specify under your data sources, and I can't remember specifically which folder that is, but I'm sure you guys are use this config file or these config files all the time. The -ds files. Are you guys familiar with these or no?
No, I'm never used
This is for JBoss. Never mind. All right, JBoss is more complicated. Hold on. I think it's context.
It was pretty much just a bunch of deployers for a bunch of fancy XML files.
Mm-hmm.
So you don't have to care much where it is, as long as it's somewhere get compiled.
This is it, right? We establish an HTTP session DS, or a data source, right? You guys are used to using JMDI names, right? That's the same as for database database data sources, and you just say that context uses cookies. Can you tell the similarity between the web config and this? It kind of has the same parameters almost. It allows you to specify the cookies. It allows you to specify the class that will handle it. In this case, it's the persistent manager, and the connection string name, or in this case, the data source name, and it can be whatever name. And you also need to configure the web.xml. It's nothing new, you know. Where do you define the data sources? I think you still need to. You see the session
it looks like you're using JBoss, so basically what you did in the context XML, you specify the JBoss and the other file in that way. Or specifying the other, one pointing to the other.
I see. Okay, so I would just use the contents of this MS-SQL DS.
Yeah.
And as you can see, I have the database name here and the server, the connection string, right? And I need to have the driver installed in the lib folder. I need to specify the username, the password, the pool size, the idle timeout, the check whether it's valid or not, the data source, and so on.
Basically, in other feature servers like Kafka. Those configurations that you were telling right now, those are going directly to the context section now.
Okay, those context sections. Okay. And I'm going to show you some code for there's also, just as it is with .NET and with PHP, there's also a Java SDK that integrates very nicely with Eclipse. And you can watch the tutorial here, and this does not tell you anything about session persistence and why this won't work, but and it'll create a package that is 90 megabytes because it'll contain, you're going to have to upload a package with Java Virtual Machine and the application server and your application as well. I just want to find where, and you can deploy also in using Eclipse. There's the Azure tools for Eclipse, and whatever we did here in Visual Studio, you can do with the Eclipse. Same type of deal. No, that's the sticky sessions, and I very highly discourage using sticky sessions. It relies on the load balancer reading the cookies and keeping a table on which user has which.
You know something funny?
Yeah.
That always has problems with production with sessions.
You should not. They're okay for small loads, but they're not good for larger loads. Never use sticky sessions for larger loads. So you're relying on a black box, basically. And try not to do the session affinity. Try to find where the persistence manager is. In this case, the context.xml, and specify your SQL Azure payment. And let me just get the where's the SDK? There's a number of libraries. Queue service. No, this is right. Install the SDK right there. And these are the classes that allow you to use the table service. I'm going to show you, like, for example, how to add an entity to a table on the table service. So you just extend from the table service entity and specify your members, and so you create the cloud storage account with a storage connection string, in which you can get that from the portal as well, your control panel. Then create a table client with the storage account, and create a customer entity just by instantiating an object, set the properties, and create a table operation of insert and execute it. inserting a number of entities as possible as well, just by specifying a batch operation and specifying which table you're going to put it in. Retrieval is very easy too, as you can say. You can just specify the generic of what kind of entity you want to cast it as, and just say, just query from people, and where, and then the partition filter. And the partition filter has partition key and comparison equal. This is just like an operator. So we're gonna get all the entities that have a name of Smith. Right? You see how this resembles a lot to NoSQL APIs? Because it is a NoSQL API. Retrieving single entities, modifying them, etc., and deleting them. So you have a number of resources here that you can use to, and the code is fairly easy. So, and all right, I think that's it. Any questions or comments to wrap this up?
Is there an overhead on the virtualization for this? I mean, something that you will have to consider about versus running in native.
Versus doing what?
Versus running a native instance of
Versus running a physical instance of the application server. It really depends. In most cases, web applications do not require a lot of resources, but they do require more than one machine serving, especially with higher loads. This avoids single point of failure and high availability. So, is there an overhead? Very small. There's a very small overhead that the hypervisor has when it comes to accessing physical resources on the physical machine, but it's negligible. Any other questions?
I don't know, probably just one about one consideration that you should have when you are moving from the current some application that you want to put on the cloud.
Mm-hmm.
What are the considerations that you should take for doing or knowing if you are a candidate for moving to the cloud?
All right, the first thing we want to do, and I'm going to move back to this. What are the considerations? What are the considerations? Make sure that session management is not in the local memory or not on the disk. That's one consideration. Make sure file uploads are not stored on disk, on the instance, and that's pretty much it. That you're not using volatile resources.
No, well, what I meant to say is, how can I know if I am a candidate for moving my service into the cloud and not leaving it?
I think that depends on the law you have. If you have a very high load, then the application is certainly a candidate for this kind of resources. You need to have a lot of fees, and you have to put this very sure you decide this kind of services.
Could be better or
to get a better meeting.
better maintenance. It would be. It's certainly eliminates the need for any infrastructural management whatsoever. That's all now managed via the little silver-like application I showed you. But the code should remain, the writing the code should remain pretty much the same. Try to keep it as if it were running on like a regular server. Now keep in mind that, for example, if you're using cache, depends on what kind of cache, right? If it's caching the output of web pages, you don't need a distributed solution. You can certainly save it to disk, because if that server gets rebooted and re-imaged, it doesn't matter. It'll create its cache again. It's not so bad. But if it's session, where you depend on real-time data and how the page gets rendered dependent on session data, then that's a different story. Does that answer your question?
I have one more question.
Sure.
Do you need to be aware of the virtual machine life cycle?
No.
For example, if you make a traditional application, you start your process system and you hope that it will run forever, and you have some watchdogs keeping your processes alive, and that's ideally what's happening in a traditional approach. But in this, you are not managing the virtual machine. So it will boot sometime, somewhere, in the cloud.
It'll boot up, yes.
Will it live forever, ideally?
Again, back to the SLAs, we need at least 2 instances for the SLA to get fulfilled. Yeah, it has automatic monitoring, and if something goes wrong, if the operating system crashes for some reason, it'll reboot it up, it'll recreate it, and re-image it, and you don't even notice that. But you can certainly see the details of that life cycle if you come here.
In case you need a monitor, virtual machine, you can do it with the system.
Also, you can also do it there. And in this case, for example, so in production, this particular site is using 15.92% of 24s, which is excessive. Let's see. It's loading. It's loading. And you can select the operating system as well. Oh, there's 2012 already there. That's good. And you can start creating more instances here right away. Right? I'm expecting a higher load. Well, then I just want to create 7 instances now. Right? And these are my 2 instances running. And that's it. Yes, these 2 are virtual machines, and you can even remote desktop it too.
Yeah, the works are different from the Java virtual machine.
Absolutely. Yeah, no, the Java virtual machines run inside these. Yeah. All right, anything else? People on the call?
No question from my side.
All right, excellent.